No, it's fine, sir.
Okay, okay.
I'll do like the questions.
To do questions, let's study properly. So let me settle it down properly. I just tried to make this and like start from here. Hmm. That takes further than. Acha, can you Dhruv write the table of 5, 10, 15, 20, 25? If you add one, then like what it becomes? 6, and then like 11, 16, 21, 26. This notation means if I take like 6, if I take 6 and write congruent 11 mod 5. The meaning of this is like these two have same remainder when divided by 5. What I tried to do, these are the multiple of 5, and this is one more than multiple of 5. Means each and every number, if you divide it by 5, will leaves one remainders in these cases. So, Dhruv, can I write 21 congruent to 26 mod 5?
Yeah.
Okay, so can I write like 26 into 5 congruent to uh, like नहीं ये ज्यादा हो जाएगा प्लस कम से चालू अरे ये क्या चलो इधर ही लिखता हूँ बराबर से नहीं तो अच्छे से नहीं आ रहा अच्छा हाँ so if I have 21 congruent to 5 21 congruent to 1 mod 5 agree is it true hello
Yes.
Saisa, did you understand this hello
Yes, sir.
so what does it means? If I divide these numbers by this, the remainder is going, both will have same remainder. Agree? So if I have 21 congruent to 16 mod 5, that also will work because you understand now what I'm trying to say. So see, if I have 2 congruent to 7 mod 5 and I have 3 congruent to like 18 mod 5. Dhruv, can I add these two?
Add?
Can I add this and this?
Huh, you can, but
If you add, then what will you get? 5 congruent to 25 mod 5.
that'll be
Is it
correct.
work? So if this is same, then you can add this, like you can write 2 congruent to 7 mod 5. You can write like 18 congruent to 3 mod 5. You can flip these two, and then add, then also will work. Agree?
Yeah.
So if I have like 100, like 1001 congruent to 1 mod 5, and then I have like either 4 congruent to like 19 mod 5. Can I add still? I
Yeah.
can add, no? Acha, do one thing. Can I multiply this? Will it work?
Yeah.
So you multiply, what will you get here? 36 congruent
21.
to 21 mod 5. So means if both having mod 5, you can add them, you can subtract them, you can multiply them, but you cannot divide them. Agree? So can I square both? If I have 2 congruent to 7 mod 5, can I write 2 square congruent to 7 square mod 5? This is
Yeah.
congruent to 49 mod 5. Anvika, are you understanding?
Yes, sir.
हाँ बेटा
Yes, sir.
पक्का चल अच्छा you tell me if I have 21 congruent to 1 mod 5, can I multiply it by 2? Can I multiply by any number? There is no battery. Only 5%. Only 5% battery. Okay. So if you can I square this, I can square. Can I multiply by some number? I can multiply by some number as well. Agree. So when to multiply, when to divide, that is different thing. So see, if I have 5 into 6 into 7 into 8 into 9 into 10, if I divide this by like 5, what would be the remainder? Tell me. Drew, what is the remainder if I divide it by 5? Isn't 0 remainder?
0.
Because if one number is divisible by 5, the number is remainder is
0.
0. So I'll take some like example, just like I'm taking 5 into 6 into 7. If I divide it by 4, I'll answer mod congruent to A mod. If I write 8, can you tell me what it will be? Can you find out A? A means this like A can be anything which will give same remainder as these multiplication gives. Agree?
2.
So are you sure?
Uh,
Pakka. So is there any other way around? So see, if I divide it by like this 8 by 5, what you will get? 5 only. If I divide this by this, you'll get same number. But there is one more thing, like this 5 can be written as minus 3 mod 8. You can subtract like 8 on it, then that also will work. Okay. So this 6 can be written as minus 2 mod 8. This 7 can be written as minus 1 mod 8. So if rather than like writing this, you can replace these by minus 3, minus 2, minus 1, congruent to A mod 5. If you multiply, it will give you minus 6 congruent to A mod 5. So now you want to make it positive, then add in this, you can add like what it was dividing by 8, sorry. So add here 8, then we'll go 2 congruent to A mod 8. So means the remainder is 2. Anyone like any problem on this concept? Anvika, if I have 2 congruent to 3, 2 congruent to some A mod 3. Can you tell me what the replacement of A that I can write here? Any more? Anvika, what I can write in place of A?
So 12.
Huh, beta?
Oh, sorry.
I can write 5.
5.
If you divide by 3, that will give 2 remainder only. Can I write here like, then add 3 on it, 8?
Yes,
Can I
sir.
write like minus 1 also? You subtract 3 on it. You can write minus 1. You can subtract 3 again on it. Minus like 4. Agree? So these all can be written. So writing negative number is also, if the number is getting reduced, then you can write negative number as well. So 2 is congruent to minus 1 mod 3. So in these like type of, always you try to get a smaller number, whether it is negative or positive. You can subtract on the remainder which comes by the divisors, that also will give one thing. So understand, you can write in place of 2, you can write it like minus 1 mod 3 also. Agree? So if I have like 5 congruent to A mod 6, what I can write here? I can write here like minus 1, 5 congruent to minus 1 mod 6. If I have 7 congruent to A mod 6, what I could write it here? Tell me. I can write it plus 1. Agree? So
or
always try to get a number which is smaller so that the applications is like easier. So now, Anvika, what did we learn? If I have 4 congruent to 1 mod 3, and then I have like, if I square it, will it work, Neil? Will it work if I square it?
yeah.
So I could write it like 4 square congruent to 1 mod 3. Agree? Can I write 4 cube also? Will it
हाँ
work? So in ulta, if you think, if you written 4 into 4 into 4, what it will be a as if you do mod 3. So if you
1 into
divide this by 3, what you'll get it? 1. Remainder, if you divide this by 3, what remainder you'll get? 1. If you divide this by 3, what remainder you'll get? 1. Congruent to a mod 3. So you'll get here multiplication would give you 1. So you'll get here 1 congruent to a mod 3. So this actually works. So squaring, cubing, whatever you want to do it, that also works. So try to reduce, try to replace this number by some equivalent number which will give same remainder as this 4 gives, and then you multiply, then your multiplication is going to be easy. So if I have like size, I have 6 raised to 100 mod 5, what it will be the smallest number that you could get? You can write 6 raised to 100 congruent to a mod 5. Saisa, what is this a minimum value of it? Isn't 1?
yes sir.
Because you write 6 times 6 times 6. How many times you can write? 100 times, and that would be a mod 5. So this can be replaced by plus 1, this can be replaced by plus 1, this can be replaced by plus 1, and then that would give you a mod 5. So these all get multiplied to 1 congruent to a mod 5. Okay, means if you divide this such a big number by 5, then remainder is going to be 1. So as if I have 6 into 7 into 8 into 9 congruent to a mod 10. Can you tell me the answers of that? Tell me what did I replace this by? Minus 4,
Yes sir.
and this beta minus 3, and this minus 2, and this minus 1 congruent to a mod 10. Now if you multiply, this would give plus 12, this would give you what beta? 2
2
congruent to a mod 10. So 24 congruent to a mod 10. So 4 is a. Agree? So when you multiply these are big number and divide it by 10 means the unit digit of this, divide by 10 means you just getting unit digit. Agree? So unit digit of this is going to be what? 4 if you multiply all of them. What if I have 6 square plus 7 square plus 8 square plus 9 square congruent to a mod 10? So that's what it will be.
16
Perfect. 16 congruent to a mod 10. Try to write below 10. So this 6 congruent to a mod 10. Means if this big number you multiply and then divide it by 10, the remainder is going to be 6. So, okay, if I have like 50 raised to 10,000 congruent to a mod 7, can you tell me what it will be? So how we can break it? You can write 50 times 50 times 50 like this. Okay. So you tell me what is closer number to 7 if in the 50. Okay. So yeah, I can write this like 50 पे closer number क्या है उल्टा लिख दिया sorry इधर मुझे 50 चाहिए इधर 7 चाहिए. Now tell me what is that like value of a? Can anyone tell me what is the value of a? Dhruv? will you get?
7 to the power of
1,000
equals
is
to a mod
a mod
50.
50. So I can write 7 raised to 2 raised to
One sec.
500 congruent to a mod 50. Agree?
It's 1. It's 1 only.
And then 749 is 500 congruent to a mod 50. So this will be -1 is 500 congruent to a mod 50. Agree? Okay, so you will understand this. This is 1 congruent to a mod 50 means if this you divide by 50, the remainder is going to be 1. Now I'll take like 2 raised to 5, 3 raised to 6, 7 raised to 8, congruent to a mod 6. Tell me the answer. Which आया? So this is तो gone
0.
anyway ना. So 1 raised to 0, 0, 6 ये इधर से. अच्छा.
Sorry.
हाँ ये 0 only ना because 1, 2 you'll get here. You didn't 2 into 3 you'll get no. Then 2 raised to 4 and 3 raised to 5. So if you get 6 in the multiplication, then remainder is going to be anyway 0, no? Okay, so you understanding what I'm trying to say from this. Now, ठीक है, you understanding that like अभी बताता हूँ और सारी चीजें क्वेश्चन सॉल्व लेता हूँ बहुत सारे. So can you do this question? If you have 2 raised to 10 plus 3 raised to 10, if you divide by 11, what is the remainder? तो पहले थ्योरम समझ लो, पहले थ्योरम समझ आता हूँ. यहाँ ऊपर से आता हूँ. दिस यू नो, दिस you understand. If you have like see, Dhruv, if you have same remainder, like what will you do in this case? Just like here you see, if two numbers having same remainder, if you subtract, then those will be divisible by numbers, no? Understand?
Yeah.
ठीक है. So this also you understand. This also we did you understand also. So if I want to simplify like 2 raised to 10 into 3 raised to 2 raised to 3 mod 7, how I can simplify that? Can't I write like 2 raised to 3 into 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 2 congruent to a mod 7? I can write like that. Now this would give you what? 1. This would give 1. All of them will give 1, 1, and then 1. And then what remains here?
2.
1. Huh? This was 10. So then 2 only. Congruent to a mod 7. Okay? That's how you can simplify it. So that would be this getting multiplied to 2 only. This much you understand. Now residual class means if you divide by some number that having same remainder, just like this 2 residual class of mod 5 means if you divide by any number like by 5, so you have to collect the numbers which having same remainder, that is called residual class. This is like the functions which give some value. So these functions, if you want to do it, then these functions I'll tell you how it comes. So if you want to get the just first solution, you have to get the prime base of it. रुक जो नीचे आजा बता दो एक दो क्लास भी आने दो थोड़े नीचे और it's like 720 का यूलर्स फंक्शन, इसको यूलर्स फंक्शन बोलते हैं, निकालना. तो just convert into prime base 2 raised to 4 into 3 raised to 2 into 5 raised to 1. If you want to get functions of that, then you do one thing. like best ways to do is this way. This way means 2 raised to 4 minus 2 raised to 3. Then you'll do like 3 raised to 2 minus 3 raised to 1. Then you do 5 raised to 1 minus 5 raised to 0. I will do this same way 720 times 1 minus 1 over 2, 1 minus 1 over 3, 1 minus 1 over 5. So I'm telling you how to evaluate this function. After that, I will tell you what is the use of it. Okay, so this is one way of evaluating. This is another way of evaluating. This thing, I think, with larger number, this is easy. So if you want to evaluate functions, this Euler functions of 720, then you write 721. All the prime base, you look into 1 minus the one prime, 1 divided by 1 prime base, 1 minus another prime base, like that we calculate. So see, Dhruv, if I want to calculate the Euler-Tillet functions of 336, how I'll calculate?
So the prime factorization is 2 squared into 3 squared.
2 square into 3 square. So I can write 2 raised to 2 minus 2.
36.
You can write 2 raised to 3 raised to 2 minus 3 raised to 1. Agree? So this is 2 and this value is what?
This is just 6.
6. So 12 is this. If I want to calculate this Euler functions of 100, then it would be
Then
2 raised to 2, 5 raised to 2. Agree? So 2 raised to
huh.
2 minus 2 raised to 1, 5 raised to 2 minus 5 raised to 1. Agree?
40.
So this value is what? 4 minus
2.
2, and this 25 minus 5. So this would give you 2, this would give you 20. So 40. Okay. So Abhi, I'll tell you the use of it. First, you understand the calculation of this. Can we do the other method, other way around also? So 100 into 1 minus 1 over 2 into 1 minus 1 over 5. So 100 into half into this get multiplied here 4 by 5. This cancel out to 2, this cancel out to 20. So again 40. So you can use either method. So if I want to calculate Euler-Tillet functions of like 1000, then what I'll do?
Sir, I didn't understand what
I'm
exactly
doing, I'll
the
tell you
Euler
what is
function
the use
is.
of it. Just give me 5 minutes. Let me first clearly tell you how to evaluate this. Agree? So you
Okay, sir.
understand the evaluation subject. You write 1000 into what prime base you have, like 2 and 5. Agree? So you write 1 minus 1 over 2 into 1 minus 1 over 5. So 1000 into 1 over 2 into 4 over 5. So 10, so 1 0 gone, so 400. Did you understand this? Any problem of anyone like to calculating this function? I'll tell you use of that. Abhi will tell you. ठीक है. Saisa, you understood now this how to evaluate?
Yes, sir.
Acha, chal, let us take one example. What is the use? I'll tell you. See, if you have a raised to p minus 1, that would give you one remainder if you divide by p, where this p is prime. Understand? This p is prime and these two are co-prime. Understand? So what I'm trying to say, if I take 2 raised to 6, it will give one remainder if I divided by if I divided by 7. Now understood? Did you understand this concept? It's not related to this. It's extension. This theorem's extension is this use of that. Just tell me. This is like this is called Fermat-Little theorem. So when you have this prime number, these two are co-prime, and this is one less than this prime number, then the value of the remainder of this is going to be 1. You can put another number, it's like 2 raised to 6 will give you 1 mod 7. 3 raised to 6 will give you 1 mod 7. And 4 raised to 6 will give you 1 mod 7. 5 raised to 6 will give you 1 mod 7. 6 raised to 6 will give you 1 mod 7. You can check in each. this is what number will get normally? This isn't, this is like 64, agree? So 64 multiple of 7 is 63. So one more. You can check for this, whether it works or not. So whenever this is prime number, this is prime number, and this is one less than prime number, and you want to evaluate this, then this is the way how you evaluate this. So I say if I apply this, I have 2 raised to 10. Okay, I want a remainder when I divide it by 7. What will you do? Can you split it like 2 raised to 6 into 2 raised to 4 congruent to A mod 7? Agree, beta? So this will give you what? Isn't it will give you 1? Because this is 1 lesser than that. So 1 into 2 raised to 4 congruent to A mod 7. So this 2 raised to 4 is what? 16. 16 congruent to A mod 7. So this is 2 congruent to A mod 7. Okay. Oh, I hope you will understand what I'm trying to do from this. So if you divide 2 raised to 10 by 7, the remainder is going to be 2. Which गड़बड़ है क्या? 2 to 10. हाँ, हो सकता है, सही है. Saisa, you understood? If you didn't understand,
Yes, sir.
I can add more examples on that.
No, sir, it's fine. I've understood.
You understood now, okay. ठीक है. See this. It was Fermat theorem. So what it says, 1 and then matlab, these two like have no common factor, and this power is 1 lesser than that. And there is called Euler theorem, which function is used here. ठीक है, will also give you one remainder when you divide it by a number n that need not to be prime. Just like we'll take example of that. Like if I have 2 raised to uh, phi n congruent to a mod suppose 100. Okay. So Saisa, what was like this n, like what was 500? What did we get? It was like 100 into 1 over 2 into 4 over 5. Agree? So this one cancel out. So this was 40. So means if you are 2 raised to 40, that would give you one remainder when you divide by 100. Understand? So it is not prime now. It is like before in the theorem it was prime, but here it is not prime. We can take two same example. If I take 13, if I have 2 raised to 12 a mod 13, and then I have 2 raised to 5 n congruent to a mod n. So if I'm taking here like not prime number, suppose I'm 14, I'm taking here, what I should put in place of that to give 1 here. Here, what it would be 1 only. ना? Dhruv, it is 1 only, ना? Agree?
हाँ.
ठीक है. और ये वाला, what it would be this like in place of that, because this is not prime number. Agree? So क्या होना चाहिए?
One second.
So you calculate, you write
So, but how
हाँ.
did you use the theorem? Because ये 100 and 2 are not co-prime.
देखो, दो चीजें हैं, मैंने बोला तो हाँ, ये को प्राइम होना चाहिए, तो यू कांट यूज थ्योरम, यू हैव टू पुट समथिंग व्हिच इज को प्राइम. ठीक है. सपोज यू पुट हियर 15. एग्री?
हाँ.
So now you can use
Then
it.
it'll work.
Then it works. So 15 into 1 minus 1 over 3 into 1 minus 1 over 5. So 15 into 2 over 3 into 4 over 5. Agree? These cancel out with this, so 8. So if you write 2 raised to 8, that would give one remainder if you divide by 15.
50.
Understand? So a lot of use of this is there, and like these theorems are very good. Like these are like too much use. So I hope you all understand this. Let me take like proper like इसका मैंने folder बनाया, मैं उसी folder पे ही जाके करता हूँ अच्छे से, तो तुम लोग better समझोगे. रुक जाओ, मैं Google Drive पे जाता हूँ. You can't see my screen, no?
No.
Okay, just have to change the settings. You then setting the entire desktop. Now can you see? Okay. So I'm going to this folder. So see, this is format little theorem that I was doing. So let me like go through this each and every question. What is the value of the first question? You know now what it is. ठीक है, this would give what? 2. This also will get, this also will get, this also will get, this also will get. This can you, Saisa, can you tell me answer of that? 2 raised to 10.
1.
Perfect, mod 11. So this power is 1 lesser than this, and these are co-prime, so the answer is going to be 1. What if I have 12 here, like 12? Then will it work? No, no? Okay, so I understand a little. This, Anvika, this, is it 1?
So 1.
Yeah, because these are like 1 lesser and these are co-prime. Then this also 1, because these are co-prime, this is prime number, these two are co-prime. This is same thing, perfect. This is 1 lesser than 19 and these are co-prime. So this is the theorem, like this theorem is written here. Now you can take this and tell me the answer of that. How will you apply the same theorem over there? Can't you write 2 raised to 10 into 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 2 raised to 10 mod 11? Understand? So you look into this and this is 1 lesser than this. So that would give you 1 remainder, 1 remainder, 1 remainder, 1 remainder, 1 remainder, 1 remainder. So mod 100. So the multiplied one, 1 remainder when divided by LS. So directly, most of the time it will not give given to you, and you have to like find out the way how to apply this. Dhruv, tell me how to apply in this. No. In this.
You can do 5 to the power of 6 6 times.
So 5 to the power of 6, 5 to the power of 6, 5 to the power of 6 into
And 5.
5 mod
Mod 7.
7. So these are the ones of 5 mod 7. So remainder
5 is
is
your
what? 5 only, no?
हाँ,
And this beta, how will you do? 11
7 to
to
the
10 you
power
need,
of
no?
10,
7 raised to like 10, how many times?
22.
2 times, no? It will give 1 into 7 raised to 2. What? 11. Now you understand this disappears, no? You can write 7 raised to 10, 7 raised to 10, 7 raised to 10, and then 7 raised to 2 mod 11. This disappears. This you have to evaluate 49 mod 11. This value is what? 44 से 5 ज्यादा, so 5 हो जाएगा ना इसका आंसर.
हाँ,
Perfect. You're getting such a big number you got remembered by using that theorem. Now tell me for this what we'll do. Same. 11 का
6,
मल्टीपल के पास जो है ना, 11 के मल्टीपल क्या है इसके पास?
10,
10. So 6 raised to 40 कर दे ना, multiple of 10. That will disappear and 6 raised to 2 mod 11. This is 36. So 3 na. Anvika will tell us answer of that.
So I think
देख
you
4
said
raised to 12 के मल्टीपल के पास जाना है तो 120 है ना.
yes, sir.
तो 4 raised to 120 into 4 raised to 5 mod 13. 4 raised to 5 is like mod 13. How you will evaluate? The theorem does not work here. Well, this is not one lesser. So how will you get remainder when divided by 13 of 4 raised to 10? You
4
can get,
square into 4 cube.
so you can write like 13 को 4 square into 4 square into 4. Okay, mod 13. So this would give 3, this would
3,
give
3,
3, this would
4.
give 4 mod 13. This is 9, 36 mod 13. So this value is what? 36 mod
10.
13 is what? You get 10, na? 10. So remainder is 10. So sometimes it is not directly given to you to find out the way to calculate. Now see, can you read and try to do this question, this wala, this is what theorem it is. See, multiply both side by p, then what it will happen? Isn't it become a? So means if these two are same, then the remainder is going to be not reduced to a only. Okay? So just like this question, tell me, 5 raised to 12, ठीक है, congruent to like a mod 13 if you do, it will be 1, no? If you subtract 1 here, isn't this will give remainder 0? Understand? So if you have like 5 raised to p minus 1, then if you do minus 1 here, then mod p is going to be 0 only, no? But if you multiply by p, then it is going to be like p only. So if you have 5 raised to, yeah, just like, can you tell me the answer of that? Like this, how will you do that? You have to prove that ki 10 raised to 18 minus 1 is divisible by 19. Is it true?
Set it to like
देखो,
equals to
10
0
raised to 18 will give you 1 mod 19. Agree? So if this
then
gives
that's
you
4.
remainder 1, and you divide, subtract 1 here. So 10 raised to 18 minus 1 will give you 0 mod 19. So this will give 0 remainder by 19. This is very good. So can we make the example on that? Like, Dhruv, if I have m raised to like n raised to 5, 10 raised to 5 minus n, okay, and I'm dividing it by like congruent to a mod 5. Can you prove something and can we generalize something on it? Like, see, if I want to take 5 out here. What I'll get here? M raised to n, see, not 5. When I take n out, then I'll get n raised to 4 minus 1 congruent to a mod 5. Saisa, can you discuss it now? What this be? So see, suppose like this 5 is co-prime with this, then this value is going to be 1. Agree, beta?
Yes, sir.
This value is this
Yes, sir.
value.
This value.
This pura value is going to be 0 because this with mod 5 will give 1 and 1 minus 1 0. So if this is not multiple of 5, then this would give you 0 remainder, means multiple of 5. And if this is multiple of 5, then this will have a factor with the 5, so this get cancelled out. So isn't this is like this would give you 0 remainder. So see, what I was trying to say, if I take n out, then I'll get n raised to 4 minus 1 mod, like here congruent to a mod 5. So my logic is, if I use the logic that this is not co-prime with this, then this is like this is co-prime with this. So this is one power lesser than, then this Fermat-Little theorem is applicable here. If Fermat-Little theorem is applicable, then that would give you 1. Okay.
So if n to the power of
That
4
1 minus
minus
1 0 it will give. So means if these are co-prime, then this remainder 0 means this is going to be, if this remainder 0, then this is going to be 0 because 0. And if this is multiple of 5, then this itself will have factor with 5 and that get cancelled out. So all in all, what I'm trying to say, this is divisible by 5. So if I take 5 raised to 5 minus 5 and I'll say what is mod 5, you'll say it is 0. If I say 7 raised to 7 minus 7 mod 7, that also will be 0. If I say like 10 raised to 10 minus 10 mod 10, that is also 0. No, not that way. You have to match the divisors and the power. Anything else you can write. So if I want to make example here, 9 raised to 5, 9 raised to 10 minus 1 mod 9 raised to 10 minus 9 mod 10. What is the remainder here? Now you understand, no? So what you have to match? This with this divisor, okay? And these you can have anything. तो अगर मैं बोलूं कि मुझे 200 raised to 9 minus like 200 and mod 9, so ये क्या होएगा? Isn't that is 0? Sasha, you understood? Anvika, did you understand
Yes,
that?
sir.
Yes.
So this is also same way. Now see, these are two matching. The remainder is going to be what? 0, no? This can we work on this question. This is very good question. We have 3 raised to 10 plus 7 raised to 10 minus 2, and we have to get remainder when we divide it by 11. So we could write this minus 2, we can break it like 3 raised to 10 minus 1 plus 7 raised to 10 minus 1. This minus 2 broke into 2 parts and congruent to a mod 11. What this will give if you do like divided by 11. So see, this power is 1 lesser than that, and these two are co-prime. So this is going to be 0. This is also going to be 0 because this subtracting one. So that way it is going to be 0 mod 11 means this such a big number, you can guess that it is divisible by 11. This Anvika will tell us the answer of that, this question.
So
Isn't one? Isn't one? See, we put change into 9 raised to 10, 9 raised to 10, 9 raised to 10, mod 11. Agree?
yes, sir.
So this is like, now look at this. This power is 1 lesser than that, and these and this 9 is co-prime, and then that way it will give 1. So everything will give 1. That would give you 1 answer. Dhruv, what is the answer of this 13? If you want to apply same theorem.
So this one is just 13 square mod 7.
हाँ, क्योंकि इसके बाद 13 raised to 6, 13 raised to 6 यही लेगा ना,
हाँ
और इसके क्लोज
या
जाएगा तो 13 raised to 2 मतलब 48 तक गया ना, 8 times,
हाँ
8 times,
so
and then
13 square is basically
13 raised
6
to
square.
2 mod 7. These values anyway disappear to 1, and 13, 14. So minus 1 raised to 2 mod
6.
7. So 1 mod 7. So it is 1 only. Okay. What about this? So need multiple of 12, no? What is multiple of 12? Closer to 1000 and lesser than 1000. So this 1000, so multiple of 12 means multiple of 3 and multiple of
996.
perfect. So this multiple of 3 closer to 1000 is 999, but this is not multiple of 4, so 996. This is multiple of 3 as well as
So it's
multiple of
3.
4.
The answer is
So
3.
perfect. You so good, guys. Like 2 raised to 996 into 2 raised to 4 mod 13. So this and this divisions will give you like this, and this would give you what? 1, and this 2 raised to 4 16 3. So answer is 3. यार इतने डिफिकल्ट क्वेश्चन मैंने आज तो शुरू किया था, आज ही मैं इधर कहाँ से पहुंच गया पता नहीं। ये तो अभी पढ़ाया नहीं, ये नहीं करने वाला, इनवर्स मैंने नहीं पढ़ाया अभी। चलो अच्छा, अब क्वेश्चंस करती है तो हो गया, ये तो पूरा खत्म। आगे जाते थोड़े। टेल मी। अच्छा, ये कैन यू डू दिस?
So
हाँ बेटा।
तो ये वाला क्वेश्चन आयुक्यू में आया था
हाँ हाँ,
2024.
कौन सा?
7 to the power of 2024.
It's easy, yeah. We can crack any question now. We are smart guys. That too, we just started. We have to spend 8 hours in this. It's been only half an hour. So like अभी तो शुरू किया है। अब Anvita is so smart. Now she will tell us what is the unit digit of that. बता करेगी क्या, उस कैसे कोशिश करेंगे? यूनिट डिजिट का मतलब बेटू क्या होता है? अगर मुझे 7 raised to 2024 करूं और मुझे डिवाइड करना है, मॉड 10 से डिवाइड करूं, ठीक है, तो मुझे जो है जो 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 रिमाइंडर मिलेगा ये यूनिट डिजिट है। सो दैट यूलर्स फंक्शन विल लर्न इट this, if this is 10, it is not prime number, so but these two are co-prime, so we could apply these theorems, but those two has to be co-prime, like those the power has to be the Euler's functions ka power. Okay, so
Sir,
you
A is it's
रुक
1
जा पहले
only.
डिस्कस करने दे अच्छे से। सो पहली बात तो 7 raised to what power I will take? Mod 10, that reduces my work, like cyclicity it goes. So to get that, I will find out the Euler function of this 10. So what is 10 into half into 4 by 5? I hope you understand what I'm trying to write. It was like number, number is 10 into 1 minus 1 prime in the factor, which is 2, which is 1 minus other prime, which is 1 by 5. So this one is like 10 into half into 4 by 5. So this cancel out, put 10, so 4. So cyclicity is 4. Understands me is you can have 7 raised to 4. You can have 7 raised to 4 mod. I'm sorry. It will give you 1 mod कितना 10. ठीक है? So that logic के हिसाब से this is multiple of 4 only ना. So remainder is going to be what? Tell me.
So
So you get 7 raised to 4 into 7 raised to 4, like that is multiple of this, keep going on, no? Mod 10. So isn't like this all will give 1 1 1. So remainder is going to be 1 only, no? Agree, beta?
Yes, sir.
Okay, so what if I change this number to 8? Can I do this again? No. Can I find out 8 raised to 2 to this 4 and unit digit? No. So to get unit digit, just like if I'm saying, oh, yeah, okay, I have 9 raised to, yeah, I have like 3 raised to, okay, like 1000. What is unit digit of that? So Anvika, what will you do if you want to find out unit digit of that? So you'll divide, you write here a mod 10. Now you know if you divide it by 10, that too also what is like what is Euler's functions of that? So Euler's functions of that is, what was Euler's functions, Dhruv? Isn't it was 4?
Huh.
So 4. So with 3, the cyclicity is what, 4? 3 raised to 4, and this is multiple of 4 only, no? So you'll get 1 only, no? चलो अच्छा ये वाला बताओ, ये देखो आ गया सेम क्वेश्चन. The remainder one 3 is to 100 divided by 7. Anvika will tell us now this one.
So we do
These are co-prime, perfect. You can use Euler's functions, format little theorem also. You can use 3 raised to 100. Like you can break into 3 raised to 6 into 3 raised to 6. Okay?
yes, sir.
And then closer to 1000 is what? Is it 996?
Yes.
Is it 996? Yeah, no? So 996, then 3 raised to 4 you remain, no? And mod 7.
So 4 is the answer.
4 is the answer. It may be 4, I don't know. Like I'm just doing it by method. So I'm finding out this, all this become 1, and then remaining is like 3 raised to 4. You can evaluate 3 raised to 4. 81. You can evaluate that. So tell me this question. Find the smallest n. This is the MC10 question. Find the smallest n such that 5 raised to n minus 1 is divisible by 13. What would be the smallest n which such that divisible by 13? So see, isn't like you look into the, like, to apply format little theorem. So what, this can be 12, no? This 13 and then 12 then minus 1, like this would give remainder 1, then minus 1 would give remainder. Understand? Isn't 12 is the answer? Or some other answers also? ठीक है. सो कोई और आंसर हो सकता है, और कुछ लगा सकते हैं, और कुछ कैन वी ट्राई एनीथिंग एल्स. सो अगर यूलर्स थ्योरम लगाया रिमाइंडर 1 के लिए, तो देन 1 तो यू गॉट इट एनीवे. सो बताओ 13 और कुछ है? 1 to 12 is, so do we have smaller than that?
So it can be, it's 4, I think.
हाँ हाँ, we can check what
4.
divisibility also ना 13 का. 13 into 2, 13 into 1, 13 into 2, 13 into 3, 13 into 4 ना. 13 into 4 minus 1 is like 0. So that sometimes it works like for other numbers also, but format little theorem, if you want to apply, then that has power has to be 1 lesser than that, would give remainder 0. Okay, so they're trying to like use that method. So ये एक एक करके अलग अलग अप्लाई किया है. What is the value of that? Isn't 0? Isn't 0? We learned this, no?
Huh.
How many 1 to 100 satisfies this? So अभी ये तो रिमाइंडर मतलब 0 चाहिए, तो 1 से 100 के बीच में how many zeros like that you can get it, like you can understand now how many of इतने satisfies, ठीक है, n. So all n you can put it also, because that works for every n. Not necessarily to prime. How will you get 2 digits of that? If you have 7 raised to 2024, can you find out last 2 digits of that? If there any,
So mod 100.
you have to get like a mod 100.
Hi, Dada.
Hi, baby.
What are you doing?
I'm just teaching them. Are you like you wanna study?
No.
Let's study. So what we could do it maximum here. Dhruv, can you try? Can we try little something to do to understand this? They said last 2 digit. Last 2 digit means if you divide by 100, what is going to be the remainder, no? So now see these are not two co-prime. This is not prime first, then Fermat-Little theorem is not applicable. Then we apply Euler theorem. So Euler theorem is applicable for Euler functions of that for that power here. So Euler functions of the 100 was what? What was Euler functions of
40.
100?
40.
40. So just go to the 40 का power इधर कितने पास पहुंचेगा? So 200 ना कि 220. So 7 raised to 20 20 or 204 like
24, no? 7.
20. हाँ तो इसमें यही जाएगा ना.
हाँ.
Okay. So this disappears. Understand or not? Now how will you get this? How will you simplify this? Can you tell me how will you simplify that? Like more you can simplify this. 2 raised to 24. So can you write 2 raised to 10 into 2 raised to 10? Understand into 2 raised to 4 a mod 100. Understand? 2 raised to 10 is what better?
So
What is?
how did 2 come?
Huh?
7, no?
Sorry, 7. But this won't work. But ये तो theorem तूने पढ़ा ही नहीं. 7 का
So
cyclicity
you
कितना होता है? हाँ?
So you can try like 7 to the power of 4 mod 100, which is 1.
That I know. 7 raised to 4 mod 100 if you try to do this is 1. Agree, you can write 7
So
raised to 1, 7 raised to 2, 7 raised to 3, 7 raised to 4. So 7 raised to 4 is 2401. Agree? You just do 7 raised to 4 is 2, like 7 raised to 4 is 2401. So my aim is now to reduce 7 raised to 24 mod, like I have to do like 100. So I could write 7 raised to 4 into 7 raised to 4 into 7 raised to 4 into 7 raised to 4 6 times of that, and then mod 100. So if I want to get this is 2401. If you open it up, you'll get it. And then others are 2401. So every time you'll get 2 digit this. If you multiply all 2 digits like that, then that would give you what? Isn't 01. So remainder is 01. So when I had 7 raised to 2024 mod 100, what did I do? I converted 7 raised to 2000 into 7 raised to 24 mod 100. Then this by using Euler's functions, this disappears, we'll give 1. So 7 raised to 24 mod 100 I have to do. This is very special number 7 raised to 4, which is 2401. And every time you get 2401, so you multiply 0101 4 times, so that would give 01. So when a number, this big number divided by 100 would give you remainder. कितना आएगा बेटा? 1. This was like very difficult question. अभी तो शुरू किया यार, MC 12 का 10 का भी नहीं. Can you tell me what is the answer of that? Is this like 31? Saja, can you tell me what is the answer of 31? How we will go ahead with this 31 question?
Sir, I think 61 will be one of
61
them
is like
because
61 is prime number anyway, no?
Yes, sir. And because 61 and 5 are not are co-primes,
Co-prime also. Perfect, sir.
and 60.
Very good, very good. और जो अच्छे क्वेश्चन है अभी तो शुरू किया है, अभी पहला क्लास है, अभी इसमें बहुत डीप में जाना है। देखो ये पास्कल का क्वेश्चंस लिया हुआ है। कैन यू ट्राई एंड डू दिस आल्सो? फाइंड द रिमाइंडर 5 raised to 40 इज डिविजिबल बाय 12। तो क्या करेंगे इसका? हम फंक्शन निकालेंगे ना उसका 12 का निकालेंगे तो 2 like 12 into 1 minus 1 over 2 into 1 minus 1 over 3. So 12 into 1 into 2 by 3. So this cancel out 2. कितना cancel out to 2? नहीं 4. So 8. So function आया 8. So answer होएगा 1. Because 5 raised to 8, 5 raised to 8. And this keep going on. ठीक है? Mod 12. So this all will give 1. So answer is going to be 1. ये वाले का आंसर क्या है?
So will you send this on the group?
I will download and send it to you all. This and the other like wo also. Today I'll give the OneNote link also where I'm putting all of that. Can you do this वाला? This इसके नीचे वाला कैली वाला जो 10th ग्रेड का एग्जाम होता है. How many prime p less than 50 has p minus 1 minus 1 is divisible by so all prime numbers except 2. Like देखो format little theorem is applicable here. You could see it. Format little theorem is applicable, and when it is applicable, you can check it. This is applicable. This is one lesser than this number, so it is applicable. And then you need to have all the prime numbers, whatever it is, that you can put it here, and then those are. So you can count it how many prime numbers below 50 you have. So how many prime numbers below 50 we have? So you can, how will you count? Twin prime number is just 6k plus minus. Once you apply, if you write like 1 is 3 anyway, you know, second is 5 7, then 12, then 11 13, then 17 19, then 23 25, no, then 29 31, then 37 30 35 37, no, then 41 43, yes, then 47, 47, yes. That's it. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 कहाँ से है? 13 ही होएगा ना? ये गलत लिखा है क्या? देखो काउंट करो कितने आ रहा है. आंसर बोला 14. हाँ 14 ही तो आ रहा है. 14 प्राइम नंबर्स आते हैं. So below 50 there are 14 prime numbers except 2. So those are like those can fit here. Ab I'm not telling you, I want answer of that by you guys. So 7
One.
raised to 100. ठीक है? 7 raised to 1000 is divisible by 50. So what will you do? I think everyone will get that. The remainder I will tell you it's 1. Can't we rewrite this as 7 raised to 2 raised to 500? Like mod, like congruent to a mod 50. So you can check it here. This is minus 1, so minus 1, minus 1 raised to 500 mod 50. So this is 1. The answer is 1. ठीक है? You can check it. So sometimes you don't need to use theorem. ठीक है? And because what is 7 raised to n congruent to 1 mod 20?
Sir, I'm not sure.
Hmm?
Sir, I'm not sure.
देखना अभी ये बेटा क्या है?
So can I try it? I think.
Try.
Sir, I think because 7 raised to 4 we done earlier
Hmm.
as
20.
2401.
हाँ.
So then that will be 1 mod 20. So it should be 4 only, right?
Yes, very nice. And theorem अगर लगाना चाहूँ तो what theorem I can apply here? ठीक है. So theorem के हिसाब से we have to find out Euler's functions for that, which is 20 into like 1 minus 1 by 2 into 1 minus 1 by 5. So 20 into half into 4 by 5. So this cancel out to 4, so 8. So you have to find like the Euler's function is 8 here. 7 raised to 8 congruent to 1 more 20, which is up to some extent it's right, because if 2401 that is also will give same one remainder. So Euler's function if you apply, but there is like smaller values also which gives you same remainder. ये वाला बताओ. लास्ट डिजिट का मतलब यू टू फाइंड आउट यूनिट डिजिट्स ऑफ दैट. तो सबका यूनिट डिजिट फाइंड करके यू टू ऐड. जैसे 1 का तो यूनिट डिजिट हुआ 1, फिर इसका यूनिट डिजिट हुआ 4, इसका यूनिट डिजिट हुआ like 9, then 16 का 6, then that we can add it, like it does not have any rules, like you can add that. There is no rules applicable. This you haven't done PNC as of now. This also you haven't done. This you can easily get. So you can apply format little theorem here to get this. We've done this. This also you can get it. Drew, how will you do 13 raised to 2026 and unit digit? Means you have to divide by 10 and find out remainder, na?
3 to the power of 2026 mod 10.
इसका mod 10 का क्या है? आता कितना है? 8 का 4.
Then you can just do 9 to the power of 1013. So then
देखो
minus 1
साइक्लिक 4 आया, इसका 4 आया, तो 4 का 3 रेस टू लाइक 10 से डिवाइड कर रहे हो, तो 13 रेस टू 4 के मल्टीपल पे जाओ ना. तो यहाँ 4 होएगा तो 4 का मल्टीपल होएगा, 2 बचेगा ना फिर.
9.
4 का मल्टीपल 2 बचा, सो 13 रेस टू 2 mod 10 you have to get, तो 13 is 169 ना.
हाँ.
mod 10 so 9. अनविका आर यू अंडरस्टैंडिंग, लाइक यू टेल मी बस, और सबको समझ में आ रहा है? तेरे को समझ में आ रहा है पक्का कि नहीं आ रहा है? तो कुछ और ट्राई करें, थोड़े और स्लो जाएं.
So I think I understand.
Very nice. You are in 8th grade and you understanding all of that. Dhruv is also in 8th grade. 8th to 9th you are, no?
Yes, sir.
Weekly you can get full in MC. This year if you get like 15, 16, but I'll make sure that you'll get 20 because it's not that difficult also if you do that kind of stuff from now on. Tell me what is the answer of that.
So we have time till November, no?
अरे मेरे को खत्म करने 2 महीने में पोर्शन, इसके बाद मैं पास पेपर 2 महीने में खत्म करूंगा, फिर मॉक पेपर करूंगा. अगर मैं सारे पास पेपर 40 years के अच्छे सारे क्वेश्चन 2 बार कर पाता हूँ, तो देन इट विल बी डैम गुड. सो फॉर दैट यू नीड अ लॉट ऑफ प्लानिंग. वैसे होता नहीं है नॉर्मली.
So full syllabus summer में?
हाँ मेरे को खत्म करना है because I want like I have 3 batches like 4 batches, this is fourth batch like this I want to finish. I want to get 70-80% like distinction this year. Last year I got 70% distinction, so this year also I want to manage same because I have good students with me. Like it's not easy to do it in that pace also. So tell me what is the answer of that. सेम 12 का तू वो यूलर्स फंक्शन निकाल लेगा ना और उसका मल्टीपल पे चले जाएगा, खत्म यार. Last 2 digits of that.
So wait, in the
You
previous question, I'm a little bit confused
हम्म.
because shouldn't the
देखो
answer be
पहली बात
1?
तो you look into co-prime of that. Those are co-prime. Agree?
Yes, sir.
Then you look into the Euler's functions of that. So 12 means 12 into 1 minus 1 by 2 into 1 minus 1 by 3. So 12 into 1 by 2 into 2 by 3. So 6. ठीक है. So this like 6 here. So this cancel out to 4. So 8. So 8 is Euler's functions of that. So 5 raised to 8 mod 12 is going to be 1. So you have to convert into the power of it. So 5 raised to 8, 5 raised to 8, how many times? Multiple of 8, which is closer to 100 is, I think 90, 96, no? You know 96? Closer to 100 multiple of 8,
Yes, sir, 96.
96. So 3 only remains. So 5 raised to 3 mod 12 we have to do. So 125 mod 12 we have to do. So 125
Hi.
mod 12. So 120 is, let's say 5 is the answer.
Sir, but if you just can you just directly use Fermat little theorem?
Betu, this has to be prime number, no? This is not prime.
Yes, sir.
So you have format, you have Euler's, you have normal method. So you have cyclicity also. So cyclicity you should know from this whole, and that cyclicity also is coming from Euler's method only. Okay, so if you have like Euler function 4 means cyclicity is 4. So that way Euler's functions of this is 8. So if you divide by 8, then cyclicity will come like 4. 8 only. So abhi you have to convert into the 5 raised to 8 power. I hope you understand that. ठीक है. अभी तो समझ में आ गया तेरे को. I think you understand. This last 2 digits of that. So you divide by 100 and then you have to find out remainder. बोलो बेटा, समझ में आ रहा है? इसमें लाइक 10 डिजिट बोल रहा है तो अभी ये तो बहुत कॉम्प्लिकेटेड क्वेश्चन, मतलब 100 से डिवाइड कर तो क्या होएगा रिमाइंडर. अब
So
100 का
you can use
फंक्शन,
Euler's.
हाँ यू कैन यूज ऑयलर्स फंक्शन. तो उसका 40 होता है तो 3 रेस टू 40 के मल्टीपल में चाहिए तो 120 तक 1200 तक जाएगा ना. सो 3
हाँ.
रेस टू 1200 is will give you one remainder. Agree? But you have 3 raised to 34 also. You have to get like if you divide mod 100 you have to get. So now how will you do that? And 3 raised to 10 is also what, like they have came up with like they converted into 7 wala power. ठीक है. You see it what they had done. अरे इज वेरी रैंडम. बाद में थोड़े अभी और थोड़े कॉन्सेप्ट सीख लो फिर करो तो होएगा. दिस इज एनीवे 0 ओनली. नहीं 2 कहाँ से आया? व्हाट इज द स्मॉलेस्ट पावर दैट यू कैन डू इट? यूनिट डिजिट ऑफ दिस इज व्हाट 7 raised to 2024. मतलब डिवाइड बाय 10 व्हाट इज रिमाइंडर? Digit cyclicity of this is this. So this is one more than that. So the answer is going to be 7 only now. How will you do this? This one. Dhruv, how will do 1 plus 7 square 7 raised to 100. If I divide by 8, what is the remainder?
So it's like a GP, so you can do the sum and then
No,
mod it.
that will screw us. Easier way. See, if you divide this by 8, what remainder will get? 1.
Huh.
If you divide this, then what remainder will get?
7.
-1.
Huh, so then that's just 0.
Then 1. Then -1. No?
Oh
Isn't
yeah, then it'll just be like
सही है ना? 1 -1 1. I don't know what answer is, but like 1, because 1 will be left out here because the 7 raised to 0, 7 raised to 1, 7 raised to 0. So 101 numbers are there, na? This,
so is that multiply or
what is the unit digit?
zero?
कैसे?
One sec.
Yes, sir. If you multiply by
Yeah.
100, so
तो एक में ही चले जाएगा. This same way ना, 10 raised to 2 है ना, तो इसमें भी पैटर्न निकाल ले.
Huh, this is also, yeah.
So 7 hour clock shows 3 now, and what would be, how many hours it will be? Like you divide by 7 and then remainder you want to get, no?
Huh. Better the 30 mod 7.
28. तो सिंपल है ना. ये 7 से डिवाइड करेगा, साइक्लिसिटी भी तुझे पता है, सब कुछ पता है, तो रिमाइंडर ढूंढ डाल इसका. तो 5 raised to 6 5 1 एंड देन जो बचेगा वो कर लेना 4. ठीक है यार, अभी मैं मतलब जा रहा हूँ, ये पीडीएफ दे रहा हूँ. इस पीडीएफ का डाउट सॉल्विंग मैं करूंगा. एक और पीडीएफ दूंगा मैं तुम लोग को. बहुत सारे क्वेश्चन इसमें ऐड किए हैं.
The
यूलर्स और
next class, what are we doing?
इसका एक्सटेंशन करेंगे, इसमें और क्वेश्चन करेंगे, क्योंकि ज्यादा अगर भागेंगे तो फिर वो कॉन्सेप्ट रह जाएगा. जैसे पिछले वाले में एक प्रॉब्लम सॉल्विंग किया था, इसमें इस पीडीएफ में बहुत अच्छे प्रॉब्लम्स हैं और सारे प्रॉब्लम्स खत्म करेंगे. और एक और पीडीएफ है इसका, वो उसका यूलर्स थ्योरम का. इन दोनों पीडीएफ्स को मतलब 200-300 पेज है, जस्ट गो थ्रू एक बार और फिर इसके बाद देख लेना क्या करना है. तो ये है, इसमें 3-4 टेस्ट भी मैंने लगाए हैं, तो मैं ग्रुप में आई एम जस्ट पुटिंग राइट नाउ आफ्टर सम टाइम्स, लाइक इन 10 minutes आई एम पुटिंग इट.